evening, viewer. Welcome to our Glory Globe TV. Here is a breaking news. Right now, the debate about consciousness often feels frozen between two entrenched positions. On one side sits computational functionalism, which treats cognition as something you can fully explain in terms of abstract information processing. So get the right functional organization regardless of the material it runs on and you get consciousness. On the other hand is biological naturalism, which insists that consciousness is inseparable from the distinctive properties of living brains and bodies. Biology is not just a vehicle for cognition. So it is part of what cognition is. Each camp captures something important, but the stalemate suggests that something is missing from the picture. In our new paper, we argue for a third path biological computationalism and the ideas deliberately provocative but we think clarifying. So our core claim is that the traditional computational paradigm is broken or at least badly mismatched to how real brains operate. For decades, it has been tempting to assume that a brain's compute is roughly the same way conventional computers do. So, as if cognition were essentially software running atop neural hardware too. But brains do not resemble von Neumann machines, and treating them as though they do forces us into awkward metaphors and a brittle explanation. If we want a serious theory of how brains compute and what it would take to build minds in other substrates, we need to find what we mean by computation in the first place. Biological computation, as we describe it, has three defining properties. First, it is hybrid, so it combines discrete events with continuous dynamics. Neurons spike, synapses release neurotransmitters, and networks exhibit event like transitions. So, yet all of this is embedded in evolving fields of voltage, chemical gradients, ionic diffusion, and time varying conductness. So, the brain is not purely digital and it is not merely an analog machine either. So, it is a layered system where continuous processes shape discrete happenings and discrete happenings reshape continuous landscape in a constant feedback loop. Second, it is scale inseparable. And in conventional computing, we can draw a clean line between software and hardware or between a functional level and an implementation level 2 in brains. That separation is not clean at all. There is no tidy boundary where we can say here is the algorithm and over there is the physical stuff and happens to realize it. The casual story runs through multiple scales at once, from ion channels to dendrites to circuits to whole brain dynamics, and the levels do not behave like molecular layers in stack. Changing the implementation changes the computation because in biological system those are deeply entangled. Beyond this exclusive report, Glory Globe to be Delhi, Bharat.